Hey everyone, in this video we will go over assembly constraints, which we will use to define relationships between all the components to create an assembly. When introducing assembly constraints to your components, the goal is to reduce the degrees of freedom to 0, or essentially not moving. To do this, you will ground one part, which will be your base part. In grounding your base part, will remove all its degrees of freedom. You can then constrain the remaining components of your assembly to that grounded part. A useful tool that we talked about in a previous video is degrees of freedom, which can be found within the View tab. When turned on, small vectors will appear indicating which direction the part is still able to move. When constraining our parts, again we will first ground one part to get rid of its degrees of freedom, then constrain the remaining parts. The two main assembly constraints we will work with are mate-mate and mate-flush, which essentially constrain two faces of two different components together. You can also introduce offsets to fix one component a certain distance relative to another object. The other assembly constraints that are available are angle, tangent, and insert. Here we have our door hinge example, and we will go through how to use assembly constraints to reduce the degrees of freedom of each component to 0. Let's start with looking at our degrees of freedom. Go into the View tab and select Degrees of Freedom. When you click this, a green degree of freedom symbol will appear, indicating the remaining degrees of freedom for each component. Currently, since we have not constrained anything, each component is free to move and rotate about the X, Y, and Z axes. Let's go ahead and ground one component of our door hinge. To do this, right-click on the component and select Grounded. Typically, when selecting which part to ground, you will choose the main component or the largest component. You can then constrain all the other components to this grounded part. Now that we have grounded this part, you can see that the degree of freedom symbol is gone, indicating that there are no degrees of freedom left. Let's go ahead and constrain the other half of this door hinge to our grounded half. To do this, go to the Assemble tab and select Constrain. Here are the available assembly constraints are mate, angle, tangent, insert, and symmetry. The mate constraint, as we have discussed, has two options, mate-mate and mate-flush. Both are used to align part features. When working with mate-mate, you can mate two faces together, which will cause the normals of two flat surfaces to oppose each other. As you can see, the two long faces of the boxes are constrained to face each other. You can also mate two axes, which is helpful when aligning holes. When working with mate-flush, you are aligning the part features but causing the normals of two flat surfaces to face in the same direction. As you can see, we've applied the flush constraint to the small faces of the box, and now their surface normals are facing in the same direction. Let's use the mate constraint to align our door hinges. First, click on mate, then we can choose between mate-mate or mate-flush. We will first use mate-mate to align the holes of our door hinge. Let's click on mate-mate, then hover over our door hinge holes until we find their axes, and we'll select that. Once you select both their axes, you can go ahead and hit apply to apply the constraint. Now you can see that our ungrounded door hinge is no longer to move in the Y direction, as it must stay aligned with the grounded axes. You can also see that the vector for the Y direction has disappeared from the degrees of freedom symbol. We can now apply the mate-mate constraint to ensure that the door hinge is properly oriented. Currently, both parts are on one side and they will not be able to close properly. Let's select the mate-mate constraint, then select the two faces that we want to mate together. Let's select the outward face of one hole and the inward face of the corresponding hole on the other part, and you can see now that the plates are both properly oriented on our door hinge. Another way to have done this is to use the mate-flush constraint. Let's cancel that constraint, and this time we'll use mate-flush. We can select the bottom face of each plate to be flush with each other. You can see that when we apply this constraint, their normal vectors are now pointing in the same direction. Let's go ahead and apply that. Now you can see that the only degree of freedom left is rotation of the other plate. We will come back to that. For now, let's constrain our pin. To constrain our pin, we can use the insert constraint. This constraint works by combining a mate of the axis of the hole and the object being inserted with a mate of the faces of the hole and the object being inserted. We can use insert to constrain bolts, pins, or any other item into a hole. Let's go ahead and open constrain, and we'll select insert constraint this time. We must then select between opposed and aligned. This is in reference to the normal vectors of the faces. We will choose opposed. We can then hover over the pin to highlight its axis and the face that we want to constrain. We want to make sure to select the outside circle so that Inventor knows which face we want to mate with our door hinge. We can then highlight the axis and the face of the door hinge hole, again taking note to select the outer edge of the face to ensure that the faces will mate properly. We can then hit apply to apply the constraint. Now when we look at our degrees of freedom, we only have rotation remaining. The rotation of the hinge and the rotation of the pin. We will go over how to constrain rotations in the next video.